Good morning, everybody. How are you all? Today we are going to talk about inference from regression. So I'll share my computer screen with you. Following our data from a small bookstore. Here is the data from a small bookstore. Number of salespeople working, which is X, versus sales in thousands of dollars, which is Y. So first it asks find the least square regression line equation between X and Y. Then compute the value of coefficient of determination, then compute the value of correlation coefficient, then it gives you the value of x equal to 12 and ask you to find the predicted cells, then the 95% confidence interval for the mean cells when x is 12, and 95% prediction interval for cells on a day with 12 employees working. And the last part is test the null hypothesis for the population slope beta equal to 0. So first we have to, so let's start the calculation. Solution. So the first thing we will do is press the second button on the top left corner of the calculator, then the plus button on the bottom right corner on top of enter, then select 4 and enter. And we will get clear all list on your calculator screen. Again, enter and you'll get done. This means the memory of the calculator had been cleared, have been cleared. So second button, plus on top of enter, then number 4, clear all list on your calculator screen and enter. Done. Okay. Now we are ready to enter the data. So we will press stat. Next step is to press the stat button. Then number 1. Stat and number 1. So enter X data in L1 and Y data in L2. So L1 is 2, then 3, then 7, then 9, then 10, then again 10, then 12, then 15, 16, and 20. Once you are done with L1, press the right cursor key, press the right cursor key to go to the first line in L2. First line in L2. Okay. And enter the Y data. Enter Y data in L2. Y data in L2. Okay. So the first Y data is 10, then 11, then 13, 14, 18, 20, 20, 22, 22, and 26. Okay, so we have entered X and Y data in X data in L1, Y data in L2. Now let's create some space here. Okay. Okay. Next we will press is the stat button. Then highlight test on the top row. That means move the cursor on test and scroll down to lin, L-I-N, lin reg. Lin reg stands for linear regression t-test. Okay. This is where you align your cursor with this test, lin reg t-test, and hit enter. Hit enter. Okay. So your X list is L1 already there. Y list is L2 already there. Frequency is 1. The next line is the alternate hypothesis, beta and rho not equal to 0. This is where the cursor should be flashing on not equal to 0, because that's the alternate hypothesis. And then we go down to calculate. Okay. And hit enter. So our least square regression line, you might say, because Y is cells. So cells, predicted cells, therefore it has got a symbol on top of it, is equal to, intercept is 8.1 plus 0.9134. X is the number of employees, or number of salespeople, times number of salespeople. Salespeople. So this is the equation of the least square regression line. This is the equation of the least square regression line. Least square regression line. This is part A. Okay. So now we are ready to do other parts. So let me create some space. Okay. So I remember it asks for coefficient of determination and correlation coefficient. So let me change the color of the ink. This color. Okay. So if you scroll down, first thing you'll do is coefficient of determination. Now let me move this a little bit. Now coefficient of determination. Okay, so we did part A, now we're going to do part B and part C. Okay. So part B, coefficient of determination of determination is, sorry, here is that, is R square. Now only for R square we will multiply it by 100%. So R square is 0.932. Only for R square we multiply it by 100%. That will shift the decimal 2 places to the right. So R square or coefficient of determination is 93.2% of the variation in Y can be explained by the least square regression model. By the least square regression model. Okay. That is the interpretation of R square. Now part C asks for correlation coefficient. Correlation coefficient, which is R. And then you scroll down to get the value of R is 0.965. What does it mean? Strong, why strong? Because it's close to 1. Positive, why positive? Because the sign is positive. Strong, positive, linear, co means together relation between X and Y. X and Y. Okay. So that's parts. Okay. Parts B and part C. Now if I move it a little bit up, it says in part D, find the predicted sales in thousands on a day with 12 employees working. So part D, let me do it over here. Part D, find predicted sales when X is equal to 12. So that will be predicted sales in thousands of dollars is equal to 8.1 plus 0.934 multiplied by 12. And we will do the calculation with the calculator. So it is 8.1 plus 0.934 multiplied by 12. And the answer is 19.31. That's in thousands of dollars. In thousands of dollars. Okay, that means $19,310. Okay. Now we have to find the confidence interval. So if I move this a little bit down, find the 95% part E, 95% confidence interval for the mean sales on days that have 12 employees working. Okay. Find the 95% mean sales, okay? 95% confidence interval. So I'll write it out here. Okay. Part E. So let me make sure I'm doing it correct. Okay, now that's correct. Part, so I have to move this a little bit up maybe. Part E. Find the 95% confidence interval for the predicted sales when x is equal to 12. Okay. Now we have already found out the mean value of cells when x is equal to 12 in part D. Now we want to find out the 95% confidence interval. Okay. So for that, we need to find out SE for the mean value of y predicted, and that is equal to square root of AC square for the slope times this is multiplication x, okay, v minus x bar square plus AC square over n. Okay, SE mu y is a standard error for the mean value of the slope. SEB1 is a standard error for the slope. SE is standard deviation of the error. Okay, let me create some more space. Okay, XV is the given value of x is 12. X bar is the average value of all x. Average value of all x. And n is equal to sample size. In this case, equal to 10. Okay. So first we need to find SE. So to find SE, okay, which is the standard deviation of the error. That means how far the errors are spread out from the fitted line. Standard deviation of error. Okay. And that we can do by stat test, the same that we did before. And we scroll down to lin-reg t-test and then run the test. Okay, so stat test, scroll down to lin-reg t-test, and hit enter. X list is L1, same as before. We just calculate, and notice at the bottom of the screen is your S. S in calculated is equal to SE is equal to 1.477. 1.477. Okay, this is the information we will need. Let me create some more space. Okay, We also need to, maybe I should move it like this, okay? We also need to find out SE, standard error for the slope. Okay, and that's a formula in the textbook. Okay, is equal to SE divided by SX multiplied by square root of the sample size minus 1. Now we will need to do press the stat button, then calc, highlight calc, then number 1. So stat, calc, number 1, one where stats, that will lead us to one where stats. List is L1, frequency list should be empty. Nothing should be there. If there's something, you press the clear button in the third row to clear it. Nothing, it's empty. And then we go to calculate and hit enter. So put your cursor on calculate and hit enter. So basically, okay, let me create some more space. Maybe you can reduce just okay. So we are interested in X bar, the average of all X. X bar, average of all X after calculate is equal to 10.4. The other thing we are interested in is Sx, and Sx is equal to 5.641. Okay, so this will help us to calculate SE, standard error for the slope, B1. This is standard error for the slope. Error for the slope. Okay, and this is given as SC B1 is equal to SE, standard error for the uh, for the residual. Okay, that is S, or standard deviation of the error term, divided by Sx square root of n minus 1. So our SE is 1.477. Our Sx is 5.641. And our sample size is 10 minus 1. So this becomes equal to 1.477 divided by 5.641. 10 minus 1 is square root of 9. Okay, so SE for B1 becomes equal to 1.477 divided by, in parentheses, 5.641, and square root of 9 is 3. So 5.641 multiplied by square root of 9 is 3. Then close the right parenthesis and hit enter. So that is equal to, standard error for the slope is 0.0873. Okay. So we will need all of this in the equation. I'll write the equation once more and I'll create some more space. Okay. So okay. So standard error for the average of y hat is equal to square root of SE square for the slope times is multiplied by xv minus x bar. This is squared plus AC square over n. So SE standard error for the average value of y bar is equal to AC square B1 we already calculated is 0.0873 and we have to square it plus multiplied by XV. We are predicting 95% confidence interval for the predicted Y for when X is 12. So 12 minus the average of X, we also calculated that and that is 10.4. Okay, 10.4. Okay, square plus SE square is a standard deviation of the error term, and that is squared it divided by n is 10. Okay, so standard error for the average value of y hat is equal to square root of, so we will square root of that is 0.00762 times 2.56 and 1.477 square by 10 is 0.218 and that is equal to 0.00762 times 2.56 plus 0.218 and that is equal to square root of 0.2375 and that is equal to 0.487. That is the standard error of the average value of y, predicted y. Okay. Now we also need to find out the critical value of t. So if I create some more space, so basically need to find t n minus 2 with degrees of freedom n minus 2 and alpha by 2. Okay. Now C level or confidence level is equal to 0.95. So alpha is level of significance is equal to 1 minus C is 1 minus 0.95. So if I draw the T chart, at the center T is equal to 0 and 95% confidence interval is in the center. This is your 0.95, this area. This is your C is equal to 0.95. So what is left? in the two tails. So area in two tails, that means this shaded region plus this shaded region. Area in two tails or area in shaded tails. In shaded tails is 1 minus 0.95 is 0.05. So because of symmetry, area in each tail is equal to alpha by 2. So this is area is alpha by 2 and this area also alpha by 2. Okay. So that is, now we know alpha is equal to 1 minus C is equal to 1 minus 0.95 is 0.05. So alpha by 2 is 0.05 divided by 2 is 0.025. Okay. So let me create some space. So my degrees of freedom for T is sample size minus 2. Okay. So n is 10 minus 2 is 8. So this curve is for degrees of freedom n minus 2. Okay. This is D, degrees of freedom. N minus 2 is 10 minus 2 is equal to 8. So I need to find this critical value and this critical value. Specifically, I'm interested in this critical value, which is T alpha by 2. Okay, critical value of T. Value of T. So I go to my calculator, second button, then verse button, then scroll down to in T, which is number 4. Scroll down to in T. So second button, then verse button in the third row, then scroll down to in T and hit enter. So your area under say in T, area is 0, area in each tail is 0.025. So type in 0.025. Degrees of freedom is n minus 2, 8. 10 minus 2 is 8. And then we will paste. Whenever we are on paste, we have to hit enter twice. Enter and enter. Okay. So we get the negative value. So we get minus T alpha by 2, which is on the left of the center, left tail. Okay. Is minus 2.306. By symmetry, T alpha by 2 on the right tail is right tail is 2.30. Same value without the negative sign, 2.306. So why do I need these values? Okay, because we have to use the equation for the 95% confidence interval, which is in the textbook. I'm looking it up and I'll write it for you. So let me create some more space. And probably I'll change the color of the. Okay. So the formula 95% confidence interval for the predicted looking at the question one more time. For the mean for the I should write it clearly. I should erase this. For the mean cells when x is equal to 12 is given by this formula. It is y predicted plus minus t n minus 2 alpha by 2 times standard error for the average value of y bar. Okay. So in our case, remember when x is equal to 12, if we go back, okay, let's travel a little bit up. Oops. So it was predicted cells was 19.31. So it is 19.31. Oh, I made a mistake there. It should be 0.9134. Okay. So there should be 0. Yeah. This was, so let me change the color of the ink to blue. And this is over here. Is 0.9134. Okay. So that will be 8.1 plus 0.9134 times x is 12. So 8.1 plus 0.9134 times 12. And that answer would have been 19.06. So if I erase this, 19.3, 19.06. So 19.06. Okay. So if I move down now, so this will be 19.06 plus minus my Tn minus 2. And that one is equal to the T value is 2.306 multiplied by the standard error of the average value, which we calculated previously as 0.487. So that is this one, this is this one, and this is this one. So it is 19.06 plus minus 2.306 multiplied by 0.487, and that is equal to 1.12. So what is my 95% confidence interval then? It's 19.06 minus 1.12 minus 1.12. The lower boundary and the upper boundary is 19.06 plus 1.12. So that will be 19.06 minus 1.12, and that one will be equal to 17.94 is the lower boundary, and the upper boundary is 19.06 plus 1.12, and that is equal to 20.18. So what does it mean with 95% confidence? We can state that the mean cells will fall between 17.94 and 20.16. Okay. So if I go up a little bit, so I believe that was part E, 95% confidence interval. Okay. And the other one, part F, find the 95% prediction interval for sales on a day with 12 employees. Okay. So that is slightly different. Okay. So we have done part E. Now we are going to do part F and then part G. Oops. I have to reduce that. Okay. I'll move this a little bit to this side. And then move up. So we did the 95% confidence interval for the mean cells. Next part, okay. I'll go back maybe to the black ink. Okay. Now we have to do the 95% prediction interval for the sales. Okay. So next thing we are going to do is 95% prediction interval. This one was the confidence interval. Now for the mean sales, now we will do 95% prediction interval for one value of sales for sales when X is equal to 12. Okay. And that formula is slightly different. Okay. That formula is Y V. Basically, this is the predicted value of Y at X equal to 12 plus minus t n minus 2 alpha by 2 times SE. Previously it was SE for the mean value of y, now it is for a single value of y. Okay. And where SE for single value of y is given as square root of SE square B1. Okay. We have already done this one, SE square B1. Okay. Standard error for the slope squared multiplied by xv minus x bar square plus SE square by n plus SE square, everything under the square root. Okay. So this is the new term that we have to find out, which is the standard error for single value of y. Okay. Now if I create some more space, we have already determined most of it. So let's do the calculation here. SE, remember this is the standard error for the single value of y at the which is predicted for x equal to 12. Now, most of the term under the square root we have already calculated. So, this is the first term is 0.0873 squared multiplied by x is 12 minus average is 10.4 square plus AC we also got previously 477 square by 10, and then the extra term is 1.477 square. Okay. So this becomes equal to inside the square root, basically 0.0195 plus 2.3996, which is equal to square root of 2.4192. Okay. So SC for the average, no, not the average, for a single value of y is equal to square root of 2.4192, which is 1.554. Okay. So we can do a 95% prediction interval for a single value of y is the predicted value is this predicted value when x is equal to 12, y we already predicted is 19.06, sorry. So this is 19.06 plus minus t already we found out is 2.306 multiplied by is this whole thing, okay, is 1.554, or this is equal to 19.06 plus minus 3.5868. And if we do the operations correctly, first is negative, second is positive. The lower end of the prediction interval is 15.47, upper end is 22.65. This is the 95% prediction interval. That means with 95% confidence, we can predict that the single value of y will fall between 15.47 and 22.69. Pretty wide prediction interval for single value of y when x is equal to 12. Okay. And now we will do the last part. So I'll change the into red. And we will move up a little bit. Test the significance of the least square regression model. Okay. So test the significance of the least square regression model. Least square regression model. Okay. This is the last part. Okay. So for us, that the null hypothesis beta is equal to 0. That means no relationship, or I should change it. Not relationship, just relation. No correlation. Okay. No linear correlation between X and Y in the population. In the population. Okay. Beta means beta is slope in the population. And we are assuming that is equal to 0 as a null hypothesis. Okay. So the alternate hypothesis is beta not equal to 0. Okay. And if I move up a little bit, alpha, as we saw before, level of significance is equal to 0.05. Okay, so what will we do? Stack, test, highlight test on the top row, scroll down to lin reg t-test. Lin reg means linear regression t-test. So you already have the data in L1 and L2. So stat, test, highlight test, scroll down to lin reg t-test, which is F as in Frank, and hit enter. So our following, let me create some space. This is, so X list is L1. It's already there. Y list is L2. Frequency is 1. And the fourth line, this is the critical, this is the alternate hypothesis, should be set equal to not equal to 0. Remember, beta is the population slope, rho is the population correlation coefficient, null hypothesis, both of them 0, alternate, both of them not equal to 0. And you go straight down to calculate and hit enter. Okay. And hit enter. Okay. So your test statistic, T, is your test statistic. Is equal to 10.466, you might say. And p-value is 6.036. P-value cannot be greater than 1, cannot be 6 point. So there has to be something which is E at the end minus 6. That means p-value is 0.000006. This is almost equal to 0. Compare with alpha 0.05. P is less than alpha. Decision reject H0. Conclusion at alpha equal to 0.05. There's enough evidence. There is there is enough evidence to support HA, to support HA. What is HA? HA is rho not equal to beta not equal to 0. Okay, so test the significance. So we have tested the significance, found that we reject the null hypothesis of slope equal to 0 and support the alternate of beta not equal to 0 in the population. That's the end of it. P-value, remember, is the probability of getting a test statistic as extreme as 10.466. That p-value is very small compared to the alpha. Remember the slogan, null p-value low. If p-value is low, null hypothesis must go. That's why we rejected the null hypothesis and supported the alternate hypothesis. So we have tested the significance and found that in the population, the relationship is significant. I will stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. Thanks for watching. If you like this video, please share it with your friend. And if you like this video, please give me a thumbs up. I'll appreciate that. I will see you next time with another interesting problem, interesting solution. Take care. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll see you next time with another problem, another solution. Take care. Have a nice day.